There has been some buzz around MLOps lately, although this technology has passed the peak of its hype cycle. That's why I think it makes sense to talk about it now. In this video series, I will go through what MLOps is and what are the common tools used. I will also focus on creating a model training pipeline which picks up data from a data lake, registers features in a feature store, and trains the model with different hyperparameters. Let's get started. Let's try to get an overview of what MLOps means. I'm assuming that you've worked with data and trained really good models, meaning you are a data scientist or someone who understands data science. If that's the case, then you must have worked on Jupyter notebooks and must have created a mess of notebooks that looks like this. I have myself been guilty of this, especially when the size of a project grows. It becomes difficult to keep track of datasets which were used to create features or hyperparameters used to get that one final nice model, or finding out exactly which version of the notebook and code was used to train the model. And sometimes, when you have to return back to your modeling project after some weeks, you lose track of the Python packages and their versions that you used. Anyone who has trained models will relate to the endless issues one encounters. Well, what I have mentioned are the issues one faces in the model training and retraining phase. But model training and retraining is not the whole life cycle of a model. There are numerous challenges that one needs to surmount when they are trying to deploy a model. One of the issues MLOps helps you with is by providing you tools and best practices to manage model training. For model training, it provides you with tools to orchestrate model training jobs, keep track of training code, hyperparameters, model artifacts, and features. For model deployments, MLOps provides best practices and tools to manage model deployments and provision infrastructure for training and deployments. Model deployments don't exist in vacuum. One needs to monitor the deployments as well. There has to be monitoring of model drift and latency SLAs. Lastly, one needs to assign different responsibilities to different actors in an ML team. Not everyone in the team should have the permission to push models into production or run training pipelines. The whole governance piece also needs to be taken care of. Now, let's see what are the tools needed to accomplish each of these four tasks. For building training pipelines, you need two components. The first is an orchestrator that can run parts of a training pipeline one after the other, as well as some tools for experiment tracking. There are two popular orchestrators that I know of. One is MLflow and the other is Kedro. You can check out these tools by simply Googling about them. For experiment tracking, one can again use MLflow or some paid tools such as weights and biases. Model deployments and training infrastructure is mostly these days created on cloud. For example, if you use AWS, you can use SageMaker to provision model training and deployment infrastructure. Other cloud providers such as Azure and GCP have similar offerings as well. Doing this well requires good cloud skills. Someone who has spent time doing DevOps will find themselves at home doing these kind of tasks. For pure data scientists, this might be a completely foreign thing to do. Model deployments require knowledge of Docker containers and container engines such as ECS, Fargate, and EKS on AWS. Model monitoring requires different tools such as ZenML or a custom-built solution. Governance is accomplished usually by managed solutions such as SageMaker, or one can create a custom solution as well. But doing so will require non-data science and ML skills, such as experience with cloud authentication and access control solutions, and good backend development skills. I think through this discussion, you would have realized that ML Ops tool space is fragmented with too many tools and many pathways to create a solution. Hence, for this video series, I will confine my discussion only on creating a robust training pipeline. I might create video series on the other aspects of ML Ops in future.